This video will be about these Hourglass kits that contain 57 LEDs and an STC microcontroller. They're available on Banggood, IC Station, eBay. They're reasonably cheap. I believe they are a learn to solder kit, which have 57 LEDs, so there'll definitely be some soldering involved. I'll show how to, first of all, the one on the right is the way it originally comes. It's supposed to mimic an hourglass, I guess. It has a button on it for selecting the speed or changing the speed. And it just plays over and over. This is the program I wrote and the patterns I put on it. It also has a button for changing the speed. Right now the program is displaying 334 pages, I believe, or something like that. 336 pages. So those are stored in EEPROM. Each page takes up 12 bytes, and it has 4K of EEPROM, so it'll hold a lot of data. The button, I didn't do as good a job of debouncing the button as they did on the original, so it kind of stalls. It kind of stalls the display when you push it. These LEDs are driven one at a time, and there's no current limiting resistors anywhere in this circuit. It's kind of unusual. So they're updated very fast to provide the persistence of vision effect. The kit comes, well, the way the ones I got came in a sandwich bag type thing. It's not the best. The pins were bent, but it was functional. I believe this was the original kit I built, and right on the back you can see right there is a jumper because one of the traces had been etched away. I had to troubleshoot that. Another thing you might want to look for when building it is you want to test every LED before you solder them in, because they're kind of a pain to unsolder. I use this little rig to check mine. It's just a battery with a current limiting resistor and two pins stuck in a block of wood. I just lay the resistors in there. I'll try to demonstrate it. You have to lay them in there in the right direction, and you can tell if it's not showing up too good, but you can tell if they work that way before you solder them in the board. The board looks like this when you get it. The LEDs are numbered 1 through 7, 8 through 13, and so on, left to right, top to bottom, until you get to number 57. That's also the way I did the program. Here's the little schematic that came with it. There's a larger version online. To program this thing, only hardware you'll need is one of these. CH340 is what I use, but any of the USB to TTL converters should work, I would think. A switch, and I use the current limiting resistor. And those are the 4 wires you need to hook up to the ISP port here. The schematic for doing that is pretty simple. You just have your USB converter here, the ISP port over here, or a 4-pin connector. You have 5 volts, ground, RX, and TX. The TX has a 220 ohm resistor in it to limit current in case this pin gets defined as an output, and this is also an output. That's just a safety thing. The reason there's a switch in the ground is because the USB converter will try to power the STC chip through its, even if you break the 5-volt connection, through its I/O pins, and then you can't reset this, and the reset is where the download process starts. So when you break the ground connection, you don't have to worry about that so much. It seems to work pretty well. I read about it online somewhere. I'm sorry, I can't remember where I read it. But this needs to be a pretty decent quality switch. You don't want to switch that bounces, because it will interfere with the downloading process. It'll start and stop, and it'll screw you up. The chip on the board is an STC15W201S. It has 1K of memory and 4K of program memory. It's a 16-pin chip. It's running on 5 volts here, or USB. I'm running it off a USB power bank. I don't believe it'll run down to 3.3 volts. Some of them will and some of them won't. You just have to look up the data sheet. There are several variations of these STC microcontrollers. They are based on an Intel 8051 microcontroller. And if you've been around for a while, you probably recognize those from late 80s, 90s. If you read Circuit Seller Inc. or magazines like that, that was pretty much a microcontroller of choice. It was widely available. You did need a EEPROM. There was a version of it, the 8751 or 8752, that had an EEPROM in it. It had this window actually in the chip, but they were very expensive and required special programming. This is the one I bought, I can't remember, in the late 80s or early 90s. It has this is all it takes to make the circuit in those old ones. The microcontroller, an EEPROM, a low order address latch. This is a RS-232 converter. They were pretty simple. I built my first one on a breadboard and programmed the EEPROM with a homemade programmer. So there's a little bit of nostalgia in using these 8051 variant microcontrollers. It has these are much faster than the older ones. This one, I've got this one clocked at 24 megahertz. You can clock it in several different ways. That seems to be fast enough for this program. It's more or less compatible with the 8051. It does have some differences, especially with regards to the I/O pin that are used on this circuit. This is the one I did. Guess I should show it. It's running through its 334 pages. And it starts up, so I'll show it from startup. Another thing about these microcontrollers is they're cheap. These were, if you buy 10 of them, they're less than 35 cents a piece. I got them from LCSC, I believe it is. Yeah, LCSC. It's a Chinese, kind of like a Chinese DigiKey. I got it within a couple of weeks for only like $6 shipping. If you order, I believe, $15 worth of stuff, there's no handling charge. So it's all very reasonable, and they have a lot of parts you'll probably be interested in. To download the STC ISP software for programming the microcontroller, you need to go to this page. I will leave a link in the video description. Over here, hit the download button. This is version 6.86. It's the latest version while I'm recording this. Download. It's an RAR file. We'll save it. I'm saving it to a temp directory. Open up the file after you've downloaded it. It's an RAR file, and I used 7-zip. I believe it was a free program for unzipping it. Right click, 7-zip. I'm just going to extract it here. It's a single file. This one right here. I would move this to another directory wherever you want it to finally live. To run it, all you got to do is double click on it. Now I will show how to create the Intel hex file that the firmware uses to display the different animations. We're on the wiki I created on GitHub for the project. We'll scroll down until we find the little editor image, and here's the link. We'll open that up in a new page, and here it is. We're running in Mozilla Firefox right now. It's going to look different depending on which browser you use. I've tried it on 2 or 3 different browsers, and it seems to work though. When you open it up, you're on page 1. To add pages, you use the Add Page button. To edit, you just click to create whatever patterns you want. You're on a new page. You keep adding pages. And you can scroll back through them using these keys. 1, 2, 3, 4, 5. Or you can drag the slider. Took me a while to figure out how to get that to work. You can also play the animation by hitting the play button. There's a speed control right here. Stop it. You can insert and delete pages. If you press the generate hex, you'll generate the hex file down here. It doesn't actually save the files directly to your machine. You just have to select and hit Control C to copy, and then you can paste them into an empty text file. There might be a better way to do it. I'll look into it a little later. If you want to open up a file that you've saved, go down here to the Browse button. I've got them stored in a temp directory. This one has 336 pages. Let's open it up. There's, I believe, a 341 maximum number of pages. It is in the documentation on the wiki, and we can play that to see what it does. Adjust our speed. Scroll around through it if you wanted to edit it. If you load another file, if you don't have the append button checked or checkbox checked, like let's load this small file here, it will just load it over the top and your old data will disappear, so be careful. That's all there is to this file. Say you wanted to build up your project in stages, you could save a piece of it and then come down here, hit the append button, and load another file on the end of it. I believe this is like 15 pages or something, and it'll just add them to the end of the file you were on. When you get ready to save it, hit generate hex. This first line contains the number of pages, but 13 I believe is hex for decimal 19. Should be. There's also checksums and things on there, so it's kind of hard to read. We'll just select the whole thing with the mouse, hit Control C to copy it. Now we're going to go to just temp directory. I have an empty text file here already set up. Open it up, right click and paste, and there's our data. We'll save it. And I'll show how to load that into the microcontroller next. Now I'll show how to download and compile the STC software for this project. I'm on the wiki page for the project right now. We'll open up the code window. The easiest way to do it, I think, is just to click here and download the zip file. I've got them going into a temp folder. Here are the main files you're concerned with. This is the C file with all the real code in it. This is the header file that's called by this C file, or included in this C file. This is the hex file. This is the compiled version. If you don't want to go through the trouble of compiling it yourself, you can just download, or you can just use this file to program into the chip, and you don't have to compile the thing yourself. This is an example data file with 236 pages. There's some images that are seen on the wiki page. So let's open up the file I just downloaded. It's a zip file. We'll right click and extract all. It'll open up the folder when it's done. It puts them in its own folder. The way I did it was I just put the C file and the header file into my SDCC compiler folder. I'll show that right now. I just copied them. Let's go to that folder. They're already in here, so I won't copy them again. But here is that file that's on the GitHub page. Here's the header file. This file right here is the batch file that we're going to run to compile it. I'll open it up in the editor and you can see it. It just sets the path so that when we run it, it'll be able to find the executables it's calling. These two lines here with remarks have been remarked out for older versions. This is the size for the 204S chip if you want to use it. This is the size for the 201S chip. This is the line that's actually executing now. Calls up the 8051 compiler with a code size of 1016, which I believe the top 8 bytes are used for something else. A couple of options. This is the actual file it's going to compile right here, HGEP2C. The output is going into this file. The IXH file is what is produced by the STCC compiler. And because of that, and we want an Intel hex file, which that is not, I'm not sure what format that is, it's some variation. You have to run this line, which converts this file into the Intel hex file. There's another marked out line. The pause is just so that the Windows doesn't shut down the window immediately after we run it, and you can see the results. So let's close that out in the editor and run it. All we'll do is open. And there it is. I'm not sure how much that you can read. There is one warning that it throws on warning 158. I believe it's line 83. This is an erroneous warning. I've got it marked in the C source file, but it compiles okay. I've looked it up online, and it's just an error that shouldn't be, or a warning that shouldn't be thrown. So it looks like it worked okay. We'll close that out, And all these files up here are what it created. The assembly file that it actually assembled. Here's the file we're going after. The hex file, that's the one we'll program into the chip. Here's the IXH file that we can't use. This one here is interesting. Let's open it up. We'll open it up with Notepad+. It shows the memory usage. Of particular interest is the, where's the line at? Oh, right here. The ROM that was used, 884 of the 1016 bytes. It's so you can see that this 1K would be used up fairly quickly. We'll just close that out. Now we're ready to program this hex file into the chip with the data file that we created with the LED editor. Now we'll try to load in the data file we just created with the LED editor. I have the STC ISP software stored in a utilities directory, in its own directory. To run it, all you do is double click on it. Windows throws up a permission box. I don't believe that OBS is showing that. Just click OK. It throws up some type of message about an EEPROM. I don't know what it means. Just click OK. Now the software will run. We have our STC15W201S chip selected. That is the chip that comes with the kit. You can select other ones like this 204. I have bought some samples of that. If you're going to do some experimenting, I would advise you get that one. It has 4K of memory, which gives you more room to play with. We've got our COM4 selected, which is what the CH340 is plugged into. Now we need to select the frequency. I've used 24 megahertz. That seems to work well, but you can experiment. Now we want to open up our code file. I've got it stored in this SDCC compiler directory where it was compiled. It's this one right here. We'll open it up. That'll go into the code buffer. Open up the EEPROM file, which holds our LED data. I have it stored in a temp directory right on the C drive. We'll enable all files since it's a text file. This is the one we created with the LED editor, so let's open it up. I'm not sure, I think that may be out of view of the OBS. Now we have our data and code in. All we need to do is program it. To do that, we hit the download button and then cycle power on the board. Download. Cycle power. And it seems to be working. And it's running our new patterns that we created. I'll turn off the lights in case there's much flicker. To program in another file, we have our code file already in there. You'll have to program them both at the same time. I don't believe there's any way to do the EEPROM all by itself. Now we'll program a different data file into the board. We'll open up another EEPROM file. Those are in the temp directory. We'll load in this one. It has 336 pages. It's a large file. Now we'll just download it. The code file is already in there. Our cycle power, it seems to be going, and it's running our new patterns. I'll try to adjust the speed on it by pressing the button. It has a lot of pages to it.